Hey, I'm Brook Drumm with Plybot, and I've got some Q&A. I've got the questions over here, so I'm going to answer some questions for y'all. Can you modify it? That's the first question. Now, I don't think changing this arm is going to be a good idea at all. Very rigid machine parts. When all is done, these are printed. If you want to add things on the top, the back, make it look pretty, can you modify it? Yes. Do we want you to? Sure. Will we support it if you tear it apart? Probably not. But we love makers, and you can absolutely hack this thing. How will the hot end and drawing attachment work? Do I need tools to change things? So there's room here for several things. The arm moves all the way around. Everything you do on this tool attachment will have to be centered so we know the location of everything. And there'll be a little nut. This is just a printed part right now, but the nut will screw on with your hand. So imagine if we had a Sharpie or a pencil. Yeah, so that fits in there, and so we'll have a tool secured for the middle. We do support a servo on the electronics, a pincher arm, or maybe machining wax. We'll see. No promises here, by the way. How does the Plybot calibrate to ensure a great print every time? There's a stepper driver, a piece of electronics that moves these steppers that will sense, trinamic steppers, when this hits the edge. So we'll be able to find the geometry of where the printer is. And as far as X, Y, and Z, that's easy. There'll be a filament sensor. So if you're out of filament, if you're stripping filament, if the filament's moving, we know that. We will be calibrating this at the factory as well. We hope in the future to add some more sensors, an accelerometer that can give even more information. What software do you recommend? When you have an STL or an OBJ, the model that you want to print, there's something called a slicer. We want you to just say, hey, here's an STL file, just take care of it, and I want to print it. That's what this printer is designed to do. But if you're a maker, if you want to get into it and slice it yourself, there's Cura, Prusa Slicer, there's all kinds of software. I use Cura, that's what I recommend. We're using a little computer on the printer. So this is a Raspberry Pi Zero W. So W stands for Wi-Fi. So you'll be able to connect to our little computer here. It's both a computer and a printer. And you can just feed it your G-code. Whatever you do to slice, we don't care. You can do different temperatures for different filament. You can do different layer resolutions, so little tiny layers or big layers. So you can feed it whatever you want. We're not limiting you and just forcing you down our app. You can do whatever you want. Are there plans for a larger printer in your future? Naturally, we want to start with something that's achievable. And so that's why these arms, are fairly small, and they'll be able to be very rigid. The bigger you get, imagine, it's kind of shocking how much distance we're covering here, so it's hard. So this type of bot where everything's suspended here at the back through these bars, the further you reach out, the harder it is to make rigid. So do we have plans for other printers? Of course. How long, how expensive, when? We have no idea, but we're really getting excited about this new type of 3D printer. I would bet on more printers in the future. Clipper is the firmware, and already it's getting geeky, right? So is it better? It's just different. We basically have to go, it's like math. We have to go to a coordinate, and no matter what firmware you run, you have to go to where you need to print. But here's why we chose it. It allows you to run a little itty bitty web server on here that gives you your user interface on your phone. We don't want a touch screen. That's expensive to put on here. And every time I use a touch screen on a printer, it's not near as good as my phone. So you have a screen in your pocket that's awesome. You can pull up your computer to operate it. We've chosen Clipper because it does this little web server. You can connect via Ethernet. What's been the most challenging parts to source for Plybot? Well, I'll tell you the most challenging part is the design. And we have a lot of custom parts. These arms are complicated. Folded sheet metal is difficult. We want to make in the USA. That already is like putting the bar really high. So to make it beautiful and to make it look and work to our tolerances the way that we want to, all of the custom parts are the hardest part. There's a few off-the-shelf parts, but I'll tell you right now, it's 2021. It's after COVID. There's a chip shortage, so to make our electronics, very difficult. Both the trinamic drivers that run the motors and the CPU that's on the electronics, even getting the Raspberry Pi, long lead times. Very difficult to make electronics right now. So that's been hard. It's been hard. Everything's hard. So everything we need to do is hard, all right? I'm not even joking. Like, all of the parts are hard. Someone asked, when focused on production, have any further enhancements or innovations been uncovered? I would say yes, but in a different way than you might be thinking. We're not doing it like I used to do, all in one location, everything under one roof. We're spread out all over the world. We have software guys in the UK. We have software guys even further out abroad in Europe. We've got Brian Rowe, who's doing machining in California. He's a specialist. Can I do that here? No. He can do it in California. Carl's making the hot ends. Paul, he's in Kansas City doing the electronics. An absolute specialist for just the electronics. Additive America, they're absolute specialists in printing these 3D parts on an HP printer. So the innovation, I think, is putting together the best team that I know of and can put together from all over the world to do one project. That's where the magic is happening here. Somebody asked a question about the Pi Zero, which is the lowest, least powerful Pi that you can buy, and a piece of software called Input Shaper. So just on a really light level, Input Shaper actually helps the resolution of the print by listening through a special piece of electronics, an accelerometer, and watching the resonance in normal printers. A lot of printers move in a straight line. So like a guitar string, you pluck it, it's going to resonate. This is even harder. So imagine if you had to forget a straight line. You're moving around in this circle, like an elliptical shape, and it's really hard. So already this doesn't have the power to run Input Shaper as it is today. Programmers could help us make it faster and more responsive to run on lighter hardware. Are we going to do that? Probably not. What you'd probably do is upgrade your Pi. So this is kind of attached to that question. Could we put in a more powerful Pi? Yes. There's this Raspberry Pi just plugs into the board through these pins. Those pins are the same on a more powerful Pi. You'll have to buy it yourself, figure out where you want to put it. Does it fit in here? Yeah, but it'd be kind of inconvenient. You'll probably want to pop it out, give it its own power, run a ribbon cable outside. I mean, it gets pretty geeky, but could you do it? Yes. Will you add another hot end, another extruder? Well, there's a lot of options here, but I'll tell you that my preference is to keep one hot end because we have to print through, something that fits at the center axis of this circle. That's how this style of printer works. So there's really only room for one hot end. We do have something we're working on. I'll give you a little teaser right here. No promises, but I'll give you a teaser. Imagine if you had 4 Bowden tubes coming down and fancy software and a couple of extra motors here. Actually, I guess one extra motor. Controlled that through magical electronics that you add onto it. And then you could have more than one color. So that's a 4-into-1 color, and we could make this possible at an extra cost as an accessory. So you can go 4-into-1. There's one caveat. Some filament prints at different temperatures than others. So there is a bit of a wait time, and you got to purge out some of the, you got to get the green out before you print the red. It mixes in there. There is a little bit of a wait time. It increases your print time. So there's caveats to this. But if you want to get super complicated, do 4 colors, do different materials, totally possible. There's just some extra steps involved. But we plan on making this more than a one color printer. It's just your choice. Hey, thanks for watching our update today. I know some of these questions get a little geeky. They don't all apply to you, but we love engagement. So we invite you to get on Kickstarter, comment, email us. We'd love to hear what you're thinking, and there may be a chance to answer more questions in the future. So send them on and we'll do our best.